Hello viewers, I'm Kausalya. Today we are going to solve problems related with DC transients. The problem is, in the circuit shown in figure, switch S is in position 1 for a long time and brought to position 2 at time t is equal to 0. So determine the circuit current. So here we are having two voltage sources, right? Initially the switch is connected to a 50 voltage source for a long time and then it is brought to 10 voltage source at t is equal to 0, right? Here again we have to find the circuit current. So this is an RL circuit, right? Now you see when the switch is in position 2, right? What will be the expression when you apply KVL? You see it is given as, let I is the current that flows through the circuit, right? So when switch is in position 2, then this is our circuit, right? So 5 into I plus 2 into di by dt, which is equal to 10, right? Sum of voltage drop is equal to sum of voltage rise in a closed circuit. Then the next thing is we are going to take Laplace transformation. So here Laplace transformation is I becomes I of s plus 2 into di by dt becomes s into I of s minus I of 0 plus, which is equal to here 10 by s, right? So I of 0 plus, it is nothing but the steady state current when switch is in position 1. So when switch is in position 1, you see the steady state current is given by E by R. So when the switch is in position 1, what is the value of E? It is 50, and what is the value of R? It is 5. So it is 50 by 5. So that gives the answer as 10 amps. Right. Now we are going to substitute this value in the place of I of 0 plus. So when you substitute, you see our expression is like this. And the next thing is we are going to multiply these two with the elements inside the bracket. So when you multiply, you see here we are having an expression like this. The next step is here I of s is common, right? So I am going to take I of s common from these two terms and I am going to shift this minus 20 to the right hand side. So this is done in this step, right? The next thing is we are framing an expression for I of s. So here I am taking LCM. So 10 plus 20 s by s, right? Now I of s is given by 10 plus 20 s by s into 5 plus 2s. So this is your expression for I of s. The next step is we are going to take partial fraction. So when you take partial fraction, you see here denominator we are having two terms. So we are splitting up into two terms, a by s plus b by 2s plus 5. The next step is when you take LCM, both the denominator terms cancel each other, and finally we end up with an expression like this. So our aim is to find the value of a and b, right? To find the value of a, you see just substitute the value of s as 0, therefore the b becomes 0. So the value of a is 10 by 5, which is equal to 2. In the next step, we have to find the value of b, right? So we have to make a as 0. So here we are having plus 5. Anyway, we have to make this part as minus 5. Then only it will become 0, right? So here we are multiplying, we are substituting the value of s as minus 2.5, right? So when you substitute minus 2.5, a reduces to 0, right? And when you solve, when you substitute minus 2.5 for the remaining things, the value of b becomes 16, right? So here now we have find out the values of a and b. So just substitute these values over here, that is in this expression. So when you substitute, you see here this is our expression, and again I am taking this 2 commonly outside because it will be easy to take inverse Laplace. So when you take 2 outside, what happens? S plus 5 by 2 becomes 2.5. So this 2 and 16 cancel each other, and finally this is our expression of I of s. Now we have to find I of t, right? So to find I of t, we have to take inverse Laplace transformation. So when you take inverse Laplace, 2 by s becomes 2, right? And this 8 remains as such, and s plus 2.5 becomes e minus 2.5 t, right? So finally this is our expression. Okay, this problem gets over here. Now we will move with the next one. The problem is in the circuit of figure, switch S is closed at time t equal to 0 on position 1 and changed over to position 2 after 1 millisecond. Right. Initially it is in position 1. After 1 millisecond it is changed to position 2. Find the time at which the current is 0 and reversing its direction. Okay, we have to calculate the time when the current is 0. Assume that the changeover of switch from position 1 to position 2 takes place in 0 time. Right. So here that is we are transferring the switch quickly. That's it. So this is your given circuit diagram. Again you see here we are having two voltage sources but opposite polarities, right? Here you see plus minus and here it is minus plus, and we are having an again RL circuit, right? So the thing is when the switch is in position 1, right, just apply KVL. So when you apply KVL, what happens? This 50 is equal to, again let I is the current that flows through the circuit. Therefore, how you will frame an expression? Your expression will be 50 into I plus 0.2 into di by dt. Right. Because the switch is in position 1 and we are applying KVL. Right. Now, for the basic RL circuit, right, we know the expression for current. So here you see I of 0 is 0 because this is the first time that the entire circuit is connected to a voltage source like this. Okay, previously it is not connected to any source. Therefore, there is no that is the value of I of 0 is 0. Now, the expression for current for RL series circuit is I into 1 minus e power minus R by L t. Right. So here I is nothing but it is the value of steady state current. So steady state current is nothing but it is E by R. So here in this circuit the value of E is 50 and the value of R is 50. Right. So just substitute the values here. And finally the value of R and L we know, right? The value of R is 50 and again L is 0.2. So just substitute and here this is our expression. Right. I is equal to 1 minus e power minus 250 into t. So when you look at this problem, you see the switch is in position 1, right, at t equal to 0. And it is changed to position 2 after 1 millisecond. Okay, that is for 1 millisecond, the switch is in position 1. Okay, this is the thing which is indirectly said here. Therefore, this is the expression for current, okay, till the value of t is equal to 0.001, that is 1 millisecond, right? The next thing is when t is equal to 1 millisecond, what is the value of current? The current is given by just in the place of t substitute this value. So when you substitute here, the answer is 0.221 amps. Right. Now we are moving the switch from position 1 to position 2. Right. So when it is moved from position 1 to position 2, you see again look back at the circuit diagram. From this position to this position. Right. So switch will fall like this. Then when you write KVL, what happens? You see here it is minus plus. Therefore, the source is minus 50, which is equal to, again, I is the current that flows through the circuit. Therefore, 50 into I, again plus 0.2 into di by dt. Right. So this is what I had written here. So this is your expression. So here it is minus 50. Right. So what is the value of I of 0? The value of I of 0 is 0.221 because initially the switch is connected to some other voltage source. Right. So here I of 0 is 0.221. Again, we are going to take Laplace transformation. So when you take Laplace transformation, I becomes I of s and di by dt dash, because in order to make a difference here we are denoting it as dt dash. Right. So it is 0.2 into s into I of s minus I of 0, and here this minus 50 becomes minus 50 by s. Right. So here the value of I of 0 is 0.221. Right. So just substitute it over here. I am bringing this 0.2 inside. right? And at the same time I am taking this I of s commonly outside. So when you take I of s outside, what happens? 50 plus zero point 0.2 into s here minus this 0 0.2 into I of 0, it is 0.2 into 0.221, right? So just substitute the values, and the next thing is we are going to move this number to the right hand side, therefore this minus becomes plus here. Then we are going to take LCM as usual, the normal steps. So when you take LCM, you see s gets multiplied with this number, so just multiply, and here is our expression, right? Now again we are going to simplify this part. So here I am going to take this 0.2 outside. So when you take 0.2 outside, the expression gets modified as s plus 250, right? So here the expression for I of s becomes, again we are dividing this entire expression by 0.2. So 50 by 0.2 is 250, and 0.0442 by 0.2 is 0.221, right? So this is your expression for I of s. So the ultimate aim is we are always expected to find the current that flows through the circuit, right? So we are calculating I of s. The next thing is we are proceeding with the partial fraction. So when you apply partial fraction, again you see this denominator has two terms, right? So here we are splitting it into two elements. Again take LCM. So once LCM is done, the denominator terms cancel each other. Again we have to find the values of A and B. So from this expression, you see, to find the value of A, just substitute the value of S as 0. So that B becomes 0. We can find the value of A, so it is minus 1. Again, to find the value of B, substitute the value of S as minus 250. You see, because here we are having plus 250. So when it is minus 250, then A will become 0. So just substitute it, and once every calculation is done, finally the value of B is given as 1.221, right? So just substitute the values of A and B over here. So this is how our expression is. The next thing is, as usual, we have to take inverse Laplace transformation. So once you take inverse Laplace transformation, so this is our final expression here. Right, we have calculated the current that flows through the circuit when the switch is moved from position 1 to position 2. So here the question, the specific question which is asked is, we have to find the time t at which the current is 0 and reversing, right? So I of t dash is equal to 0. Okay, we have to find the value of t at which the current is 0. So in the place of I of t dash, just write it as 0. So here this is our expression, right? So when you rearrange, this minus 1 when moved to this side becomes plus 1 here, right? So again 1 divided by 1.221 gives 0.819. So taking ln on both sides, right, our expression gets modified like this. Therefore, the value of t dash is calculated as 7.987 into 10 to the power minus 4 seconds. Okay, this is the time duration at which the value of current reduces to 0. Right, here comes the end of this problem. If you have any doubt, let me know in the comment section. Thank you.